All right, this is chapter 10, questions 4, 5, 6. Just a little review. A sample of a gas occupies the volume of 635 milliliters at 722 torr. At constant temperature, what will be the new volume when the pressure changes to the following? So for this question, we're going to be using the formula P1 times V1 equals P2 times V2. Pretty important. P1 V1 equals P2 V2, where P is pressure, V is volume, P1 V1 is initial, P2 V2 is final. So if we've got a volume of 635 milliliters, okay, that's 722 torr. That means that we got to do 722 torr times my volume, 635 milliliters, equal to, oops, there we go, is going to be equal to what volume at a pressure of 2.5 atmospheres? Well, actually, hold on. What do they want this answer in? They want this answer in this and this. Okay, so two ways I can do this. I can turn the atmospheres right here into torr, or these torr to atmosphere. Doesn't really matter. Should give us the same thing. But let's do 2.5 atmospheres into torr. So 2.5 atmosphere. Well, for 1 atmosphere that I've got, I have 760 torr. So here atmospheres cancel out. So 2.5 times 760. Yeah, 2.5 times 760 real quick. 1 second. And that gives me 1,900 atmospheres. Wait, hold on. Torr. Sorry. So 1,900 torr. Okay. So what will be the volume at 1,900 torr? Let me just erase this real quick. Alright. So if we multiply 722 times 635, well, what's the volume? So 722 times 635. Okay. And then we divide that, well, actually 760 times 722, excuse me, times 635 gives me 458,470. So 458,470 over 1,900. That should give me the volume. Get out of here. That should give me the volume. Okay. I got 241.3 milliliters. That's my volume 2. So we went from 635 milliliters to 241 milliliters. All right, next we got to do part B, 795 milliliters of mercury. Now, 1 milliliter of mercury is equal to 1 torr. So pretty sure it should be the same. Now, if we do 722, wait a minute, let me see if I get, let's do something a little bit different. Let's try to use atmospheres. Thing is, 760 milliliters of mercury is equal to 1 atmosphere. We'll see what happens. Okay, so we got 722 torr times 635 milliliters. Okay, equals to 795 milliliters of mercury. Now we have a 1-to-1, so 795 millimeters of mercury means that we've got 795 torr. I'm not gonna complicate it and switch to atmospheres or anything like that. I was gonna, but we gotta save time on this. So let's just multiply these out. 722 times 635. Let's do it up here. Hopefully it doesn't give me a wrong answer. So 722 times 635. 458,470. And then we do 458,470 equals 795 torr, and the second volume, V2. So now divide 458,470 over 795. What's that equal to? 576.692. Let's just reiterate, make sure. 576.692. Yes, right, that's right. So 576.692. Let's round that up to 577. 577 equals V2. And of course, that's in the liters. Alrighty, pretty good. Given 6 liters of N2 gas at negative 25 degrees Celsius, what volume will the nitrogen occupy at, got two choices, 0.0 degrees Fahrenheit and 345 Kelvin. Okay, so this one's going to be slightly different. This is going to be new formula. V over T, volume over temperature, I believe is equal to volume over temperature. Okay, so we got volume 6 liters over the temperature, negative 25 degrees. But for this one, if I remember correctly, the temperature has to be in Kelvin. So we have to convert 25 degrees Celsius to Kelvin. So look it up. We're looking at it real quick. So at negative 25, we got 248.15 Kelvin. So negative 25 degrees Celsius equal, what are you going to solve for, buddy? Okay. 248.15. Let's just get these all out of the way. So for 0.00 degrees Fahrenheit, we're going to get 255.372. 255.372. Okay, and then 345 Kelvin. That's easy. That's just 345 Kelvin. Okay, so we got 6 liters. Just do this one over here. 6 liters over 248.15 Kelvin is equal to a volume, I don't know my volume yet, over the second temperature, which is going to be 0 degrees Fahrenheit or 255.372 Kelvin. So all we got to do is solve for V, do a little cross multiplying. $255.372 times 6 is going to be equal to 1,532. 1,532.232. That's going to be equal to 248.15 times volume. So all we got to do is divide 1,532.232 by 248.15. Let me finish this real quick. 248.15 K. And then we're going to find the volume. Okay. So this should give me 1,532.232 over 248.15 should give me 6.17. Okay. Or 6.17462, but that 4 is not big enough to make me round up. Alright, and then we got 345 Kelvin. So same deal, 6 liters over 248.15 Kelvin is equal to some volume over 345 Kelvin. So we cross multiply. 345 times 6 divided by 248.15, and that's going to give us the second volume is equal to 8.34. If y'all want to see that, same thing, guys. 345 times 6, it's just a cross multiplication, is equal to 248.15 V. This 345 times 6 equals 2070. If we divide that by 248.15, that gives us 8.34.